Dax, what is the equation if it's exponential? You want to ask a friend? A times b to the power of x. Okay, so let's go back to the question. At the start of a carnival, you have 50 ride tickets. Each time you ride the roller coaster, you have to pay 6 tickets. Isaac, do you think this is something that's growing or decreasing exponentially, or just in a linear manner? Hayden, what do you think? Do you think if I have 50 ride tickets and I have to pay 6, is that decreasing exponentially or more linear? Linear. Yeah. So the keywords that we're looking for to know if it's growing or decreasing in an exponential manner would say you have to pay half your tickets, or three times your tickets. It's multiples instead of just a single thing. So this is our y-intercept. And I actually, when I'm doing them for word problems, I know it's not slope-intercept form, but this makes more sense most of the time when I go in word problems. I start with this amount, so I kind of want it first, and then I'm showing the increase or decrease. So either way is acceptable, well, especially because we pushed slope-intercept form too much. But don't you guys agree when you read the word problems, this makes more sense as you read it? I think so. Okay, let's find one that's specifically, let's do E. Sorry, will you read E for us? Harder picture, exponential or linear? Exponential. Yeah, so these, you'll start to recognize these key words. I don't feel like they made it that difficult to notice, actually. So Bailey, how would I write the equation for this particular problem?
It would be 2,000 times parentheses 1/2 breadth, and then parentheses
Power of x. Okay, so once you got going on those, I felt like they were pretty obvious. They weren't trying to trick you on any of them. Okay, let's go to the second page. Number 2, decide whether the table represents linear or exponential function. Say it again. On that second page? Yeah. That was actually the one I was going to start with because it was a little bit tricky. We have so much paper this year. I know. Okay. E has this table. I'm not going to do the whole thing because I think we just need a couple of these numbers to figure out what we're trying to find. So, Mandy, when you see this, would you say this is exponential or linear? Yeah, this is how I would start to decide. 50 minus 15 is 35. 35 minus 15 is not 24. So even if you can create a subtraction or an addition problem right here, if the pattern does not continue, that's how I know it's exponential. Maybe the decimals, but I don't know that's consistent. So I'm going to be looking for A. Okay, then it specifically wants us to write an equation. The 50 is easy. So here's how you can find the factor, that base number, if it's not obvious, which I don't think it is. We do know that 50 times whatever that is has to give us 35. Do you all agree that? Yes. Like we know that. That's so write that equation down by number or by letter E.
50 times.
Yes. We don't know what B is, but we know that if we do 50 times B, it will give us 35.
Oh, that's B.
Yeah.
I don't know why I thought it was a 6.
These and 6s look similar.
You can just do 35 divided by 50.
Well, that's what we're going to do here. I think some people have a hard time just memorizing things, though. So, and I think we can all set up this equation. So like Carter said, if we do 35 divided by 50, that will tell us our value for B. And I turned mine into a fraction. My calculator originally said 0.7.
Yeah.
And I don't know, it seems like we pretty consistently made that a fraction. That was a good question. The rest of them, I feel like were more obvious than that. This is clearly cutting the numbers in half, but having a fraction for a scale factor is difficult where there's a numerator and a denominator. Okay, any more you want me to do on that side? A, B, C, D, E, or F, or G? All right, turn that paper over to the number 3 problem. Raise your hand if you did not get to this page yet. You? Okay, let's look at number 3 then. It says make a table for and then I think there must have been some editing errors because it says make a table and there's nothing over here. Like you have to almost look in the table. So
It's over here.
I think when we were printing it or formatting it, took this equation over to the side. I was kind of confused.
Somebody double spaced, mentioned blank space.
Yeah, something definitely happened there. I mean, I know the equation's inside the table, but it would have been nice if that was not above the linear one. Okay, so when we go to fill out this table, if it tells me that x is 0, 1, 2, 3, 4, and 5.
Which equation do you use?
So within the table, it does specify. So if you look at the table, both of them have the equation they want you to use at the very top. So the directions look very misleading and unorganized, but within the table, it has the one that it wants you to use again. All right, so one, if it tells me that x is 0, 1, 2, 3, 4, 5, what do I do with that to fill in the rest of my table? What do I do with those x's?
You put them in.
You multiply it by the half, you add the a, you plug it in. There's a lot of ways to say it. So you could do a lot of these easily on your calculator or in your head. And then same thing here. We're going to take these 0, 1, 2, 3, and we'll plug it in for this x.
One thing you use fractions or decimals.
I don't care. I prefer fractions. Actually, if I on this one I did decimals because they were like 0.5, and on this one I did fractions, but it didn't specify. If it doesn't specify, you can pick. Go ahead and fill that out. You have not already. I'm not sure how important the rest of this is. It's kind of a long worksheet. Once we're done filling that in, I'm going to have you guys turn it in and I'll grade it that far. And if I find that there's problems like the remainder on your test, I'll just give them back to you and we'll work on it another day.
Let's call if we did all of it.
Until 3?
I wasn't going to count it as extra credit, but I'll see how many of you did it. Why, do you need extra credit?
Yeah, I do.
I think I have 120.
I do too. Are you concerned that it's not going to stay up there? What's that?
Wait, what? What is he gonna stop importing this one?
So once you get done filling in these tables, so the y values, we'll just, as far as doing this, we're going to just scan them in at that point.
So we don't have to see them before.
No.
Sweet! Good, I didn't finish number 5.
When I have confused, does it matter if you use
If it's a fraction,
a have a difference?
yes, you need to, otherwise it'll be only the one is being raised, and one of the two also.
Number two.
I don't trust it.
I thought it was down.
Oh, well, now you trust it.
It's gone, dude.
You're gonna be able to smell cancer down there.
You can smell the future with this juice.
No,
Did you get 9 from this?
no, it shouldn't have thrown this away.
Did you say
This
first
card,
card?
which was, one of my friends handed me this completely filled out because he didn't want it. Like, when I was walking back from the assembly, he just handed this to me. And I'm like, what? So I may or may not have spoilers on how to do this.
Is this what this is?
Spoiler alert.
Yeah.
Still had the paper,
Yeah, I like
just rename it. A lot of piano people. So they'll be like, yeah,
Wait, so you don't want us to do 4?
No, that's okay. Alright, so once you get done with those tables, you can just turn them into the turning basket. When I upload this, it looks like I don't have the same problem as this paper. Does it appear the same way?
Oh, maybe, just like your paper.
Yeah, we're supposed to start with the notes side though, which apparently I don't have. Okay. I wasn't able to load this side of the worksheet. I thought it was on the PDF.
It's not like
It's
paste,
not.
it's like the very back.
Okay, so let's look at the top of this paper. We've been talking about exponential growth and decay, but this is a little bit different. So maybe I've been using those specific terms a little bit different. So when you guys look at these equations, it has the growth equation. It has y equals, which is the same, and then a, which is the same, and then it has r plus 1 to the power of t. Does everyone see where I'm looking? Y equals a, these are familiar. Okay, so let's explore this for a minute. Gabriel, what do you notice that is different from the equation that we've been talking about since Monday? Yeah, what did we call that before now? Yes, we were just calling it a single thing, b, the base of this exponent, and now they're breaking it apart in two different things. Okay, Kimball, what's another difference even between the two of these?
You already said the 1 plus r to the power of 2 was supposed to be right?
Yeah, yesterday, the day, Monday, Tuesday, Wednesday, those were just b, so it's changed a little bit so that we can see the difference between the two. So what else is different? Yes?
In the side of the parentheses, one has plus r, and the other has 1 minus r.
Yes, please do something, like maybe write it a little bit bigger up above. These equations are very small. I want this to be something that you really notice. So up above the equation where it says exponential growth, put a plus sign. And up above where it says exponential decay, put a subtraction sign. Those are a very minor looking thing, but it's going to depend on if it's growing or decaying. Okay, there's one more thing I'm noticing that's different from Monday, Tuesday, Wednesday. Maybe.
Power of, like the power is,
It's a t. And Monday, Tuesday, Wednesday, what did we have for the exponent?
X.
We had an x. So the reason why, which I think it mentions, it's just kind of small, this is going to be the amount of time that's passed. Specifically, the amount of time that something's been allowed to grow or decay. All right. Let's look down at some of these examples that they're giving us. Let's break them apart a little bit. We've got y equals 172. Most of this is pretty straightforward, except, so everyone write down the initial amount, which is a, that's the y-intercept. Except what is a on this one? So it says A is the number that's right next to your equal sign. What is it for this one? Say it again? Yeah, what is it for this equation? Which number is it in that spot? Yeah. Okay, here's the only thing that I think is difficult about today's lesson. It wants the rate of change, but it specifically says as a percentage. So please start out by putting 0.3. Put it as a decimal, please.
I know the, like, you know what, it's all,
Yeah, we're gonna change it to a percent in a sec. What are you saying, Ethan?
to get it to a percent, you just, fun thing is, you just take whatever on the side of the right, and what I do is I just flip it all the way to the left. It's like
So what percent do you think this is?
30%. Out of one.
You flip it all the way to the left?
Yeah, you just make it 2 decimal.
All right, so in order to change something from a decimal to a percentage, which is what we're doing here, you're going to move that decimal 2 spaces to the right. If you hate that method very much and you make mistakes, you can also multiply it by 100 on your calculator.
I got 10. Oh, wait, there it is.
That'll accomplish the same goal. So especially, like for example, if I'm supposed to move this decimal 2 spaces to the right, but there's only one number there. Yes, so you'll put zeros. If there's empty spaces, you put some zeros in there. We don't need this one over here anymore, right? So again, 0.3, we move our decimal 2 to the right. So it kind of looks like this now. That seems like a silly percent though, don't you think? Like you would never see a percentage like that.
The trick I gave is only works for like,
2 digits?
it only works, yeah, if there's a 0 and then a dot, and then any singular number by itself, because if you put another number, then you're times it by like a power, and then increasing and so on by just moving it all the way down.
Yeah.
But it is simpler to do than moving the decimal point when it's just simple like 0.3.
Well, all the ways are simple. Just make sure you pick one that is consistent for you. If you start mixing between the two, it's going to get confusing. All right, so let's look at the one below it. I really wish these were already written up here. That would make my day so happy. So one, what is the initial amount in this equation? 50. Kimball, what is the decimal rate of change?
0.25,
And what's the percentage?
25%.
Yes, I think these ones are easier, the one that's already have 2 decimal places here. You can go straight to the percentage. Some people need this lesson though. Not everybody already knows how to do this part. Okay, let's do the next one, because again, it looks kind of weird also. They're not all exactly the same looking, if this is something that you don't know how to do. So, Mandy, how is this one looking different from the other 2 that we've done with growth?
There's not a rate of growth.
Yeah, they've added them together already. So, you might need to separate it. 1 plus 0.75. The exponential growth is pretty easy to separate because it's 1 plus a decimal. So, Max, what is the A or initial amount? And Kason, what is, where are you calling me last time? What is the rate on this one? What's the percent?
Just 75%,
Yeah. thinking though?
175%.
Before you just change this into a percent, break it apart so that it matches the formula. Cause it's just this part, that's the rate. The one is a part of that equation. Okay, any questions on that rate of growth? All right, let's go look at the decay. Just again, they're just enough different. Let's talk about what we would do. So y equals 12, 1 minus 0.35 t. Ollie, what is our initial amount for this one? 12. 12. That part's luckily easy. And what is our percentage going to be for our rate of decay?
B 35.
Yes. For a minute, I was wondering if it needed to be negative 35, but that negative is part of the equation. Okay, let's look at the next one. Isaac, what is our initial amount?
360.
Yes, 360 of something. And Dax, what is our rate of change in percentage?
9%. Or not, or 90.
These are the ones that I think are tricky, where it's only one digit, and we've got to make sure we remember to move it twice and to put a 0 in that spot. So if you were also thinking 9, write yourself a note out to the side. Put a star by these ones. Yeah? What would 9% look like as a decimal? What if it was, there is such a thing as 9%.
0.09.
Yeah. So there's going to be an extra 0 there, because 9%, that's a thing. It's just not this one. So they kind of look funny. These are the ones that are just a little bit tricky. You have to be careful. Don't go too fast. Okay, that last example of decay did what the last example of growth, where they've already combined them. Yeah.
1% is 140.
So we've got to figure out, we've got to find that value. They already subtracted them. We need to find the value. How would you go about doing that if you can't do it in your head?
I just add 1 to the 10.
Oh, do 10 minus 4.
What? 1.
So grab your calculator, yes. If they've already subtracted them, because it's not actually 4%, it's not 40%, it's not 140%, it's none of those things. We have to find that missing value. We've got to find the mystery. So in your calculator, type in 1 minus 0.4, or if you can do that in your head, do that in your head. It's like 1 minus 40 cents. That's how I think of it. If I'm trying to do that in my head, I think of it like money. Like $1 minus 40 cents. My mind immediately goes to money.
0.6.
Yes. Please write this stuff down so that if you get to one like it and you're not sure how to find the rate, it'll remind you. So, I don't remember where I left off. Carter picture, what is my initial amount for this one?
550.
And Seth, what is my rate? In percent? Yes. So sometimes we want to call it 6% because we just don't remember. And sometimes we just get going too fast. So don't go too fast on that part. Okay, let me look at this next part, right? The exponential function. Will you turn it over and do 1 through 8? Just practice for a minute. I'll walk around with an answer key. Start with numbers 7 and 8. I think those are the hardest ones. So go 8, 7, 6, 5, 4, 3, 2, 1. So when I walk around, I can see if you caught on to how to find that rate of change if they already did the addition or subtraction. So on these bottom, there's these bottom 6 problems, like a second table down there. Okay. Kimball, what would your equation look like for this one? I'll start you out with a y equals,
Y equals 49.5
1 plus what?
1 plus 0.09.
I hope you guys all tried that one
5.
by yourself.
So I'm going off the actual figures run.
Did I not write it down right?
There's 9.5% of that if you don't.
Okay, let's look over to the right-hand side. I'm gonna go to the very bottom right, where it says it's decay. Again, I think this looks just weird enough that I want to show you how to turn that back into a decimal. So, okay, what do I do to move this back into a decimal from a percentage? So what will that look like? Yes. Yep. Okay, there's a part on the worksheet that we have not gone over yet. Here's what it would say. One entire side of your worksheet says, it's like word problems. So it says, let's say this is the amount of money that somebody is losing. So they bought stock in Twitter, and it changed owners, and so it's decreasing exponentially, okay? They might say, how much money will the stock be worth after 6 years? So you have lots of words. You have to figure out your equation. So when it says, how much will the stock be worth after 6 years? What do I do with that 6 to find out this answer? It's actually the time. They would have had to give you the initial value of $42,000 the stock is worth. They would have had to tell you how much it's decreasing by. Then they'll give you this additional information. So if the time is 6, what do I do with that? Where do I plug it in? Or the T. And I would just use your calculator for this. I don't know why I wrote a 9. To the power of 6. All right. You should be very, very ready for the front. One single example wasn't enough for the back. We'll have to go over some first thing tomorrow. We'll see. Ready. Just one. You're gonna obviously halfway. Not sure why. Okay, go ahead and get started on the front. You're definitely ready for the front. If you get stuck on the gut free